Hi, my name is Cha Long. Nice to meet you. I am the mascot of BioPlus China. Today's topic is how to make PCR, so follow me and let me take you guys to the lab. So firstly, welcome to the course of producing PCR. Now let's learn. You may have watched criminology movies where a forensic expert takes the DNA of an object in the crime scene and then uses it to determine the criminal. A question asked by most is, how do they do this? Well, there's a kind of technology called polymerase chain reaction, PCR, and it is involved in this field. PCR is used to analyze DNA and can make extensions of DNA with semi-conservative replication. You may think, oh, then isn't this just DNA replication? Well, while DNA replication functions the same as PCR, there are a few notable differences. First, DNA replication uses DNA polymerase and PCR uses Taq DNA polymerase, which is a kind of polymerase extracted from bacteria in hot springs, indicating its ability to tolerate extremely high temperatures. Second, DNA replication is controlled by cells, meaning that we might not get the genes that we want the cells to replicate. However, PCR makes it possible via designer primers. Quick note, there are a lot of polymerase used in PCR besides Taq DNA polymerase. However, they will not be specifically discussed in this video. Moving on, what materials should we use in PCR? Generally, PCR's components include the template strand, primer, dNTP, and buffer. The template strand is the DNA sample. The primer is the short segment of DNA used for starting DNA replication in PCR, as we will talk about a bit later when discussing dNTP. Buffers are used to provide the ionics environment for PCR, especially the magnesium ion providing the prosthetic group. The prosthetic group contributes to the catalyzing characteristics of enzymes. By attaching to enzymes, they allow enzymes to catalyze substrates. In such cases, it will boost the activity of Taq DNA polymerase, accelerating complementary base pairing. Let's talk a bit about the procedures for PCR. They are denaturation, annealing, and extension. Temperature set in the denaturation step ranges from 90 to 98 degrees Celsius, and the step's aim is to separate a double-chain DNA into two single chains of DNA. This is the reason why we use Taq instead of normal DNA polymerase. Normal DNA polymerase cannot withstand the temperature and will be denatured in the process, decreasing work efficiency in the following steps. The annealing step requires a lower temperature. The specific temperature depends on the content of GC base pairs. This is because GC base pairs has 3 hydrogen bonds, making it stronger than AT base pairs, which only has 2. This step aims to bind the primer to DNA by lowering the temperature. If the temperature is not low enough, the specific binding of the primer and DNA single chain will be broken again. Hold on, what is specific binding? Specific binding is when there's only one position on a DNA single chain that primers can bind to. Let's take a look at DNA sequence ATT-ATTT as an example. We will design a primer to bind with this DNA single chain. If we design the primer as TAA, then we will not succeed because TAA can bind to both ATT in the first section and ATTT in the second section. But if we design the sequence TAAA, we will have a chance to succeed. There is only one position that can bind to TAAA on the single chain, ATTT. Thus, we can call this specific binding. Let's move on to the third step. In this step, the temperature will rise up to about 72 degrees Celsius. With Taq, the primer will start from the mentioned position where specific binding takes place and replicate from the 5 end to the 3 end. While the primer is moving, it attracts the dNTPs to the template via hydrogen bonds. dNTPs are actually deoxyribonucleotides, a nucleotide that contains deoxyribose. And there are 4 types of it: DATP, DTTP, DCTP, and DGTP. For example, if DNA sequence ACTG is on our template, then it will attract the 4 types of dNTP to the template strand. So that's all the process to make PCR. Thank you for watching. I'm Cha Long, and see you next time.